Match Fishtank, Unit 8, Lesson 1, Anchor Problems. In this first anchor problem, we're asked to connect 5 different data sets with 5 different questions. So we can simply start by reading one question at a time and trying to identify what type of answer it would give us. Question 1 is flip a coin 10 times. How many heads did you get? Well, we could get anywhere from 0 heads to 10 heads in there, and we would expect any number in there, but probably the most of them are going to be about the middle. Data set A doesn't give us 0 to 10. It only gives us 0 to 3, so it's probably not that. Data set B gives us 12, and we can't get 12 heads by flipping a coin only 10 times, so it's not that. Data set C gives us 6, 5, 7. Oh, that could be an option for it, so I'm going to put a little mark by it. Data set D gives us 6s all the way across. I don't think if I asked 10 people to flip a coin 10 times that I would get 6 heads every time. No, that's not a good answer for this question. And data set E, well, I see an 11 in there, and I can't get 11 heads by flipping a coin 10 times. So question 1 is data set C. How many books did you read in the last year? So I'm not going to look at data set C. Data set A. Well, it's possible that the most number of books a 6th grader read is 3, but that doesn't seem very likely. Data set B. No, I don't think every 6th grader will have read exactly 12 books in the last year. We've already analyzed that data set C belongs to question 1. Data set D says 6s all the way across, and again, I don't think that it's very likely that they all will have read the same number of books. Data set E includes 3, and it goes all the way up to 16, 2 to 16. That seems like the best answer for this one, because it seems likely that some kids would have read only the books required in school, and other kids would have read a lot more. So I think data set E is the best candidate for question 2. What grade are you in? Well, we're told that this survey was given to 6th graders, so it's got to be data set D, because they're all going to answer 6th grade. All right, how many dogs or cats do you have? I only have 2 options left. One has all 12s, and one has numbers from 0 to 3. I think that data set A is the best candidate for a data set with dogs and cats. And finally, how many inches are in 1 foot? Well, that's 12 every single time. So that's going to be data set B. I noticed that question 3, what grade are you in, and question 5, how many inches are in 1 foot, are different from the other questions because you get the same answer every time. Scroll down here. So if you didn't watch the previous video that gave you a mini lesson explaining what a statistical question is, you'll want to know that a statistical question is one where we can answer it by getting a data set. In other words, by getting different answers from different people. And we do expect that those answers will be different, not all the same all the way across, like what grade are you in asked of 6th graders. So, how many days are in March? Well, we're going to get one answer all the way across, no matter who we ask. If they're answering it correctly, one answer. So no, that is not a data set. That doesn't give us a data set, so it's not a statistical question. How old is your dog? Well, for everybody who has a dog, their dogs are probably a slightly different age, so that would give us a data set. On average, how old are the dogs that live on this street? You could argue either way for these two. If I'm asking how old is your dog to just one person, then it's no, not statistical. If I'm asking the same question to people who live all along a street, then yes, it is statistical. So you need to make sure that you phrase these two so that you're asking the question of different people. If you're only asking one person, then B is definitely not statistical. What proportion of the students at your school like watermelon? If we're asking a bunch of people, do you like watermelon? Do you not like watermelon? Then that does indeed make it a statistical question. Do you like watermelon? If we're just asking you or just asking me, the answer might be yes or no, but it doesn't yield a data set. If, like in the example before, we're asking multiple people this question, then we can get a data set. How many bricks are in this wall? Not a data set. We can count them. There is only one correct answer. What was the temperature at noon today at City Hall? This is another case where if we ask a bunch of people in a bunch of different cities, we'll get a data set. If we're simply talking about our city, then we won't get a data set. So remember that a statistical question has to be one that gives us a data set for an answer. So we really need to be asking more than one person if it's a simple kind of question like, do you like watermelon? And we expect to get different answers from people. If it's a question like how many bricks are in this wall, the only way we'd get a different answer is if somebody got them wrong. Scrolling on down to question 3. Marcus has 25 baseball cards. So if I'm thinking about baseball cards, and MLB, if you don't know it, is Major League Baseball, I could think of some things that are both numerical and categorical about those baseball cards. Numerical data would be things that would give us a number. So I could ask, what are the batting averages of each of the players on the cards? Or how much is each card worth? An example of categorical data is something that's not a number. For example, I could say, what team does each player on the cards come from? Or something like, what was the name of the different players? That's not even really categorical data there, because it's not going to give me, it gives me a different answer for every person, not something I can really analyze with statistics.